Hello my friends, welcome to my channel. And today my channel Math and Stuff with uh, Samson Paul. And today in this video I'm going to explain to you about chain rule and solve five easy problems on chain rule. uh, Probably some complex problems will be solved maybe in one of the future videos. So this is the videos series of differentiation where differentiation is explained, and in this particular video I'm going to explain how to solve chain rule. Now chain rule is basically used to solve functions inside functions. Okay, so probably I could uh, remind a way, teach you in a way which my professor taught me about 15 to 18 years ago. And uh, how he taught me was that consider a rose, right? Consider a rose or a flower, any flower for that matter. I'm just going to draw this is not a rose. I mean, this is kind of a like a lotus. Let us call it as lotus or something like that. Consider a rose, and it is covered with consider any flower which has a lot of petals. Okay, let us say this is lotus or a rose which has a lot of petals. Now imagine you want to get to the center of the rose. You want to remove the center of the rose, which is deep inside here, which is somewhat deep inside here, the center part of the rose, which is located here. Okay, and what is happening is you have no access to it, so you start removing petal by petal, starting by outside petal first. First outside petal comes out first, then the next inside petal, then the next inside petal, then the next inside petal, until you reach the inside of the lotus. Okay, or let us say rose. Okay, one and the same. So this is how my professor or my teacher taught me a long time ago, and I have still considered this way, and this is the way I teach my students. Now okay, so how do I explain chain rule to you is very simple. Imagine you have a big function of y. Let us say a function of y, f of g of um, f f of g of k of okay, so we'll not use k, we'll use l of x. Okay, so a function is actually hidden in one function. So one l is the most inside function, g is the next outside function, and f is the outermost function. Okay, so how do I solve this is the challenge in differentiation. So this is one of the challenge in differentiation. So the solution to this is very simple. What you have to do is, like you are opening the lotus or the rose petal by petal to get inside, you have to use function by function to get inside. So the meaning of this is that when you differentiate the outside function first. Okay, so you differentiate the outside function first, f dash of g of l of x. Okay, then you differentiate the inner function g of l of x. Okay, and then after that you differentiate the inside function. Okay, the most innermost function, and that's how it goes on. If you have n functions, you will have so many number of derivatives. So this is how the chain rule works. So basic definition is chain rule is a method, okay, is a method used to solve differentiation of functions hidden inside functions, hidden or embedded inside functions. They're not actually hidden, they're actually functions embedded in functions. And these problems are pretty interesting, and I'm going to solve around 5 problems for now, which are very easy ones. Then probably in the next video I will solve some of the complex problems. Let us start with 5 problems for now. Let us go with the first problem. This is the easiest problem that is there. So let me copy this and let me go to a fresh part where I can paste this and solve the problem. Okay, let me go to a fresh part here and let me solve the problem for you here. Okay, and let me say Control V. Okay, now how do I solve this problem? Okay, now problem is 3x plus 1 whole square. Okay, again there are 2 methods to solve this problem. Okay, one is just applying the formula a plus b whole square, splitting it into a square plus 2ab plus b square, which I am not going to solve because there is no much chain rule hidden in this. Okay, other one is directly differentiating like this. Okay, so how do I approach this problem? So first I consider the outermost function and I try to solve it. The outermost function in this case resembles something like x to the power n. Okay, x to the power of n, or let us, instead of x, let us use u to the power of n. This whole term is nothing but u. Okay, so now what you are going to do is, let us do it in that way. What I'm going to do is, I'm going to substitute a function u in place of 3x plus 1 and write down y as u square. Okay, and then I'm going to differentiate y regularly using the formula which I use for x power n. Okay, which I use for x power n. So the formula I use for x power n is dy by dx is 2 times u. Okay, now is it complete here or is there anything else to solve? Now you should remember that u is a substitution given for 3x plus 2. So again you have to differentiate u with respect to x. Okay, so this is the inside function which are supposed to differentiate with respect to x. Okay, so then your problem is complete. Now there is no function inside u, so you can just differentiate this and find out the differentiation of du by dx, which is nothing but 3, right, which is the differentiation of this function, that is 3x. Differentiation of 3x is just 3, differentiation of 1 is 0, that gives you 3, right? So that will give me 2u times 3. Okay, and that is nothing but 6u, and in the end, last step, you are supposed to write, okay, you're supposed to write 6 3x plus 1 in terms of x, because your problem began in terms of x. Okay, problem began in terms of s. In the initial classes, in the initial times when you are solving, it is best to use substitution like this. Let us say t, or let us say u. Use a substitution like this for the function which is inside and go on solving that function to come outside, and then you can basically in the later days you can do it is the easier way. okay, a more easier way, or a single step method. Now if I were to do, I'm quite advanced now in differentiation, so if I were to do this problem, I would directly do this problem. Dy by dx is equal to 2 into 3x plus 1 into differentiation of d by dx of 3x plus 1. I wouldn't even write this, I would directly write differentiation of 3x plus 1, that is just 3, and that will give me 6 of 3x plus 1. Okay, so this only comes with practice. So if you practice a lot in chain rule, you can directly do this, but in the initial days I would highly recommend you use the substitution t or u. Okay, based on this, let us go to the second problem here, which is again similar to the previous problem which we solved, where you have 30 as one of your equation. I am just going to paste the problem right here, and I'm going to solve it right here for you. Okay, so I'm going to solve it right here for you. So how do I solve it? Again, I will use a substitution. Now I can see there are only two functions here. Okay, one is this function, okay, and one is this function, the power function and the power, and embedded in that power function there are other functions, okay, the power functions. Okay, so how do I solve this? So I can take, so if it is too difficult for you to start with, you can start by taking t. Okay, you can start by taking t as 7x to the power of 5, okay, and start solving function by function. But I pretty much feel that after have gone through my videos, and after you have done a little bit practice, x to the power of n formula is pretty easy for you, and you will have had some practice with these problems. Okay, so let us just take for now t is equal to, okay, this x to the power 1, so t is equal to 1 minus 4x plus 7 x to the power of 5. Okay, you can take t or you can take u. Now when I solve this, I will write dt by dx is equal to differentiation of 1, that is 0, minus differentiation of 4x, that is 4, plus differentiation of 7x plus 5, that is 7 5s are 35 x to the power of 4. So my final differentiation will be 35x to the power of 4. Okay, 35x to the power of 4, right? But if I were to write this outside function, my outside function is t to the power of 30, right? So if I were to differentiate, okay, dy by dx, I would get, okay, dy by dt into dt by dx. And this is just one more way of showing your differentiation. Okay, what I am trying to tell you is that when you express y in terms of, which will be clear, I will clarify this more clearly in the next problem. In the first problem I did not do it because it was very complex in the first problem to take it up, so I took it a little bit simpler there. But I think now in this problem I can explain it in more detail. Now dt will get cancelled and you will get dy by dx. So first you differentiate y with respect to t. So you find out dy by dx into dy by dt, that is 30 t to the power of 29 and dt by dx. Okay, and then dy by dx is nothing but 30 t to the power of 29. dt by dx I have already found here, and I'll write it as 35 x to the power of 4 minus 4. Okay, in the end, don't forget to replace this t in terms of x. That's an important step. Lots of my students also forget this. If you forget this, probably you're going to lose some marks in your examination, because your final answer should be with respect to x. So dy by, because you're differentiating with respect to x, Okay, so dy by dx is 30 times 1 minus 4x plus 7x to the power of 5 to the power 29 into 35 x to the power of 4 minus 4. All right, so this is the answer for the second problem. Now quickly let us go to the third problem. Okay, there I think I solved the third problem. Let us go to the second problem now. I might have mistaken with the uh, first, second problem and third problem. That's okay. That's not a problem at all. Let us kind of go to the second problem now, and I'm going to transfer this problem as low as possible for me so that I can kind of pan it for you guys and show it in a different location. Okay, so let me say cut, and let me just paste it here. Okay, so let me just paste it here. Okay, control V, right. So now, okay, all these functions only contain two functions, and I have purposely given only two functions for the reason that at this stage, if you were to take more than two functions, it would be quite difficult for you to understand. So what I'm going to do is I'm going to again use a substitution here, u as 13x square minus 5x plus 8. Okay, and my y will be nothing but root u, or also my y will be nothing but you actually don't know a formula for root u. There is no general formula for root u. So what you can do is you can express it as u to the power half. Now this resembles x to the power of n. All right, so this way you can solve the problem. Now let us get into the problem. Dy by dx is equal to du by dx, sorry, dy by dx is nothing but dy by du multiplied by du by dx. Okay, now why I am multiplying is you have introduced an intermediate function where this depends on u and u in turn depends on y. Okay, imagine you have 5 functions like this. You might have to do dy by dx is equal to dy by du into du by dv into dv by dw into dw by dx. I am definitely going to solve one problem which will involve more than two functions. Okay, that is coming up in the next video, but for now let us stick to the simple problems. Okay, now how do I solve this? Dy by dx is nothing but dy by dx is u to the power half, so half u to the power half minus 1, okay, into du by dx. Right, let me process this further a little bit. Dy by dx is equal to half times u to the power of minus half. U to the power of minus half is again can be expressed as 1 by root u. Okay, so this whole term can be expressed as 1 by 2 root u. Okay, just simplify, you will come to know 1 by 2 root u. Du by dx is nothing but differentiation of this, so with respect to x, so 13 into 2 into x minus 5 into differentiation of x is 1 plus differentiation of constant is 0. Okay, so further simplifying further, dy by dx is equal to 1 by 2 root u, 13 2s are 26x minus 5, and then I go further down and write dy by dx is equal to 1 by 2 root whatever u is, I think u is 13x square minus 5x, 13x square minus 5x plus 8 into 26x minus 5, right? So this is one of the important problems that I kind of recommend you to solve. First, start with two functions. Okay, so we have already solved um, um, we have already solved 3 problems. I will solve the 4th problem and 5th problem for you. Okay, and pretty much maybe I'll just solve the 4th problem, and 5th problem you can probably take it as exercise, because oops, I'm sorry, I think I deleted it instead of cutting it. So what I'm going to do is I'm just going to solve the 4th problem and give you hints on how to kind of solve the 5th problem. Okay, let me copy it here. Okay, let me solve the 4th problem here for you. Okay, so 4th problem is y equal to 2 to the power of cot x. Okay, so before going into the 4th problem, I'll just quickly give you an hint for the 5th problem. All you have to do is you have to do y 3 tan and express u as root x. From here I think you can solve. Okay, express root u as root x. Okay, and you have formula for tan directly, root x just now we solved, so I think it's pretty much easy for you to solve. Okay, now without even using substitution you can solve this problem, and in this particular step I am going to show you in detail 2 methods. Okay, one using that substitution which you use u, okay, and 2 methods, that is method 1 which is substitution, and second one is direct method without using any substitution. Okay, direct method. Okay, now how do I solve this problem? It's pretty simple to solve this problem. All you have to do is dy by dx is equal to, okay, so before, first we will use the first method. I'm sorry, before we go there we will use the first method and express t as cot x. It's not cos. Okay, t as cot x, t as cot x, and we know that y equal to 2 power t. Now we have a formula for cot x and we have a formula for a power x. This is not x power n, this is a power x. So what will happen is dy by dx is equal to dy by dt dot dy dt by dx. Okay, and that is nothing but dy by dt is 2 power t log t, okay, into differentiation of dt by dx, that is differentiation of cot x, is minus cosecant square x. Okay, so my final answer will be dy by dx is equal to 2 power cot x, okay, log of cot x, and I'll take this minus sign here and write minus here and just write cosecant square x. Okay, cosecant square x. Now coming to the direct method, let me use some other color. Direct method, this is much more simpler and I think you'll appreciate this method very easily. Okay, and this is the method I told you, with practice you can directly solve this method. Okay, Now directly you think about the outermost function, it is a power x. So all you have to do is directly do dy by dx is equal to, think this as in your mind, think that there is no 2 power cot x, you have a power x. Okay, but it is not a power x, actually it is a power t. In your mind you just think that outermost function is a power t, and you directly differentiate and apply the formula, you get 2 cot x into log of 2 cot x into log of cot x, because that is the formula for a power x log a, and d by dx of cot x. Okay, it's kind of a direct method, you can solve it in one line, and this is nothing but dy by dx is equal to 2 cot x, I'm sorry, 2 to the power of 2 power cot x log cot x minus cosecant square x. Okay, this minus is inside the bracket, it's multiplication. Okay, so this is how you solve, and will give you the same answer. Okay, and quickly I can show you one more example that comes to my mind. Y equal to log of 1 plus x square. Okay, so if I were to solve this problem, how can I solve this problem quickly is dy by dx is equal to, outermost function is log, so differentiation of log x is 1 by 1 plus x square into d by dx of 1 plus x square, which is nothing but 1 by 1 plus x square into differentiation of 1 plus x square is nothing but 0 plus 1 plus 2x. Okay, and your final answer is 2x by 1 plus x square, 2x plus 1 divided by 1 plus x square. Okay, so this is kind of a direct method. I would recommend for the first 10 problems you solve, use a substitution t or u. Okay, and then start using direct method for the next 10 problems, and then it will be more easier for you. Okay, and this is just 2 functions. In the next video I'm going to show you if you have chain rule with a lot of functions. I hope you had fun with this video, and do let me know in the comments what would you like to learn more, and I wish you happy learning.